section 7.1, what we are going to look at is estimating something for a population proportion using a sample. Mainly what we'll look at is creating what's called a confidence interval. So the idea behind a confidence interval is that we want to say something about the population proportion, and we'll call that P. So, but in order to say something about an entire population, I need to use a sample, because that's only feasibly what I can actually track down. So then I will use what's called a sample proportion. And my sample proportion, the letter L still uses P, but to denote that it's a sample, we'll put a little hat on it. So we're actually going to call it P hat. So these proportions, whether it's for a sample or a population, remember that proportion is just a decimal or a probability. It's going to be some value between 0 to 1. I always think of the P's as probabilities. It also is a proportion. It's basically any decimal value between 0 and 1. So if we continue along, what we're going to be looking at for these problems is things that are normally distributed. And if we're using things that are normally distributed, we're talking about we want to use z values again, just like we did back in chapter 6. But this time we're going to do it in relationship to proportions or probabilities or percentages. Think of all the P's as kind of meaning the same thing. Probability, proportion, percentage. So if we look at this, suppose a voice from on high told us that 64% of all Polk State College students wanted to change the name of Polk State College to Polk Community College. Now the key here is they're talking about all Polk State College students, and that's a probability or a percentage or proportion of all the students. We've talked about this before. When you have a probability, proportion, or something for all or everyone, that means an entire population when they use the word all or every. That means we're talking about the regular P without the hat on it, because it's not a sample. It's for everybody. It's an entire population. That means our P, our probability, our proportion for everyone, is that as a decimal, the 64%, which is 0.64. That would favor the changing the name from Polk State College to Polk Community College. The problem is we don't have people that can track down every single student at Polk State College so we can actually find that value. So because we can't track down the entire population when it's not feasible, what we're going to do is we're going to use a sample, and we're going to use that sample to estimate it for the entire proportion. For the entire population, we can't do it. So what we're going to do is we're going to use a sample to estimate it. And we're going to create what's called a confidence interval for these proportions. But the first thing that we'll do is start by finding the value of our P hat, the proportion for our sample. Well, we'll start out by writing it as a fraction. We'll start out with the proportion or probability or whatever value it is that we're looking for. We'll start out with a fraction, which will be whatever we're looking for will go on top. And then our total sample size goes on the bottom. We'll divide that out and turn that into a decimal, and that will be our proportion P hat for our sample. And then we're also going to want to find what's called a Q hat. Well, just like before, P's and Q's added up to 1. Same thing here, even though they're for a sample. P hat, which is our sample proportion, and Q hat, which is also a sample proportion, still have to add up to 1 or 100%. So that won't change. And they a lot of times will call these p-hats and q-hats a special name. They'll call them point estimates. So the p-hat and q-hat are what they mean when they say they want point estimates for the proportion p and q. So let's take a look at more of what we're going to do with these p-hats and q-hats. What we're going to do is create what's called a confidence interval. In our confidence interval, we'll look, or let's shorten it to CI, will look something like the following. Confidence interval will have a starting value and an ending value that we'll find. And what will be in our center now, I know we're used to using the mean, but we're talking about proportions now, is instead of our sample mean being in the center, our sample proportion will be in the center, the p-hat. And we're going to have the calculator do most of this for us, but we need to understand what's going on. The calculator will also find what's called this E, which stands for a margin of error. So E stands for a margin of error. And what it does is it takes your p-hat and adds the margin of error to get the higher end of our confidence interval. And on the lower end of our confidence interval, it takes the p-hat and subtracts the error. And again, the p-hat, the actual proportion for the sample, goes always in the middle. We'll deal with what it actually means and a little bit more details later. But in order to create these confidence intervals, we have to be given a level of confidence. And this level of confidence that we're given is going to be a percentage. So we'll say something like we want to have a 90% confidence interval for the population proportion, blah, 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 blah. So we'll have some kind of percentage. And to actually use it just like anything, we'll convert it into a decimal. And the calculator will do a lot of the heavy lifting behind the scenes. But again, we'll have something, it'll be given in the problem. It'll be something like, let's say, an 80%, 90%, 95%, 99%. We'll see a lot of different percentages. And what it allows us to be is, let's say, 80% confident that our interval that we create, and we'll have a starting and a stopping point, is that our proportion for the entire population, our P for the entire population, will be 80% confident that our value for the entire population is somewhere in between the starting value that we come up with and the ending value that we come up with for our confidence interval. Continuing along, so it's very important that we understand the setup of a confidence interval, because the entire chapter 7 is based on these confidence intervals, where we have these starting values and we have these ending values, where we're trying to say something about an entire population, but we can't track down the entire population, so we have to use a sample. And in 7.1, we're specifically focusing on proportions, whereas on, let's say, 7.2, we'll focus on means, and on 7.3, we'll focus on standard deviation. But we're going to be doing the same concept over and over and over again through chapter 7. It's just in different contexts. And how we do each type of problem will be different, but the context, the ideas behind the confidence intervals will always stay the same. Before we